Hello students, welcome to part 2 of the chapter Some Basic Concepts of Chemistry. In this part we are going to see about matter, nature of matter. So the first question is, how can you define matter? What is matter? So anything that you see around you and that has mass and occupies space, anything that see around that has mass and that occupies space can be called as matter. So if you look around, you will see that there are a lot of things around you, and there are only such things that is having mass and matter. So can you name something that is not matter? Yes, of course, there are things that you can feel but does not have mass and space. For example, sound. Another example, if you are moving, you will have some type of energy, you have potential energies, you have different types of dreams. These things, they don't have mass and does not occupy space. Such things cannot be classified as matter. So anything that has mass and occupies space is called matter. So what about its classification based on its physical state? So from the lower classes, you might have learned about different physical states: solids, liquids, gases, etc. And there is still one more physical state called plasma, which is of natural origin. So solids, liquids, gases, and plasma. And there is one man-made physical state, it's called condensate. So all these so all these physical states are there, but for us, in our syllabus, we have to concentrate on the three physical states, mainly solid, liquid, and gas. So you can see these three arrangements of particles, and these three corresponds to three physical state. In solids, though, the arrangement cannot be always in an ordered fashion. So here what you see is arrangement in an ordered fashion. In solids it is not always they have this order, but in certain cases they have this order. Anyway, particles are much close to each other and they lack that freedom of movement. So these particles, once it is having a position, it has to stay there. It is not allowed to move. Clear? So that's solid. And when it comes to liquid, particles are close to each other, but they have that freedom of movement inside the liquid. They can move inside the liquid. And when it comes to gas, particles are far away from each other and they can move freely. So this is the basic difference between solid, liquid, and gas. Now if you're going into a little bit more detail, you can see that in solids, particles are close to each other and are not free to move. And since they can't move, we can say that solids are rigid. It's very difficult to separate or move that particles. You can see this from this figure. This guy is trying to hit hard so that he can separate the particles. He is separating one part of the rock for making some sculpture or something like that. So since it is rigid, it is very hard to remove particles from this solid. And because of this rigidness, they possess definite shape and volume. They can have a definite shape and definite volume, which we see around almost all these solids we see around us is having definite shape and have a definite volume. And in the case of liquids, we have the particles close to each other, but they are free to move inside the liquid. They are free to move inside the liquid. Since they can move, these liquids can flow. We have seen this, almost all type of liquids are able to flow. Anything that can flow is commonly termed as fluids. So for solids, they are rigid because of their restricted movement, whereas in the case of liquid, they are able to flow, hence they are called fluid. In the case of liquid, it can flow, so it's called fluid. So you can see from this glass of water, it is still moving. This movement is due to their freedom of this particle. So one thing what we have to be careful is that it can move inside. It cannot move outside the liquid surface. It cannot move outside. So because of this, they possess a definite volume but does not have a definite shape. They have a definite volume. So if you take this volume will be a constant. If the temperature is constant, this volume of the liquid that is it is contained is a constant, whereas it does not have a shape. So what is the shape? It will take the shape of the container. Liquid will take the shape of the container. So this is liquid. And when it comes to gas, there are a lot of space between the particles, and because of this space, they can even freely move everywhere. So they are not restricted to move inside the gas, they can move outside the gas. So that means that they can flow. So they are also called fluid. So what are fluids? Fluids are two physical states, both the liquid and gas can be commonly called as fluids. Both can flow. So you can see that this is from the cup of coffee, water vapor is coming out and it can move easily out of the cup. So that means that because it can easily move out of the cup, it neither have a definite shape nor a definite volume. So it does not possess both volume nor shape. So what is its volume and what shape? So if you are trying to contain this gas inside a container, if you are trying to take this gas inside the container, then that means that that gas will take the shape and volume of the container. So if you try to contain this gas inside a closed container, then you can say that the volume of that container is the volume of the gas. You can say that the shape of that container can be considered as the shape of the gas at the moment. But when you split open that container, this gas will escape from that container, then there is no more shape and volume. Okay. So that is gas. So you can see three physical states of water here. First one is the ice, that's on the left of your screen. In the middle of the screen you can see its liquid form, that is water, liquid form of H2O, that is water, and on the right side you can see water boiling and water is escaping like as water vapor to the environment. So we have three physical states. From this figure itself you can identify which is having the higher temperature, which physical state is having higher temperature. Of course it is the gaseous state which is having higher temperature, and as we come to the liquid, it is having lower temperature, and below 0 degrees centigrade it's having it's in its solid form. That means that temperature increases from solid to liquid, then from liquid to gases. Maximum temperature is for gases and minimum temperature is for the solids. That's why when we cool down this water, it will try to condensate into water. Then water means its liquid form, and when we further cool below 0 degrees centigrade, it starts freezing. So you can say temperature increases from solid. For solid, temperature is minimum, and when it is liquefying, that means that its temperature increases, and when it is above 100 degrees centigrade, entire water will form or will move as water vapor, entire water. So in this temperature you can see both water and water vapor. Details about these things we will learn later, but for the time being, temperature increases from solid to gas through liquid. And in the other case, pressure. Since what is pressure? Pressure is force per unit area. So for the so you can say that if the number of particles increases in a particular volume, then pressure increases. And we know that maximum number of particles is for solid. So pressure will be maximum for solid, least for the gases, and liquid will be in between that. So pressure increases from gas to liquid, and then maximum for solid. So physical state of matter can be interchanged by changing temperature and pressure. So that's the advantage, that's the relationship between this temperature and the physical state. If you change the temperature, you can change the physical state of matter. And the same is the case with pressure. If you apply temperature, it slowly moves from left to right. If you apply pressure, it will move from right to left. So this is what you can see. Heating will take physical states from solid to liquid to gas, and applying pressure will take physical state from gas to liquid to solid. So if you are heating, it will first melt and form liquid, and on further heating it will evaporate as water vapor. Applying pressure, gas will liquefy into water, and if you are again applying pressure, it may solidify. Okay, now again classification of matter, but this time at macroscopic level. So let us take matter as a whole. Matter can be broadly, so you can see one type of matter is pure substance. So the question is, what are pure substances? Pure substances contains only one type of component, one type of particle inside it. Pure substance. For example, pure water. What does that mean? Pure water means it has only H2O molecules inside it. Has only H2O molecules. If it has only H2O molecules, no any other particle inside, no any other molecule inside, then such a container or such substances are called pure substances. So it contains only one type of component. Clear? Now if you look into the pure substances, you can see that there can be two types of pure substances. Pure substances can be classified as elements or compounds. How can we differentiate this? So elements and compounds, that means it belongs to pure substance. What is pure substance? It has only one type of component. And this pure substance that has only one type of component is classified as element when it has only one type of atom. So it can be a molecule or an atom, but doesn't matter. If it has only one type of atom, we call this as an element. Can you say an example for this? Yes, we have noble gases which stays only as element. So if you are taking only stays as atom. So if you are taking noble gas and if no other gas is inside that, you can say that it is pure substance and it is in atomic form. Whereas if you are taking hydrogen gas, what is the formula of hydrogen molecule? H2. And what are the atoms it contains? Only hydrogen atom. And if it contains only hydrogen molecule in the container, if this container contains only hydrogen, H2, that means it is pure substance because it contains only hydrogen, and the other hand it contains only hydrogen atoms. So these molecules, H2 has only hydrogen atom inside it, hydrogen. Or if the container contains only oxygen, it has only oxygen atoms. What is the formula of oxygen molecule? O2. O2 is made up of two oxygen atoms. So then it can be also metals, Fe, iron for example. If it is pure metal, then it contains only atoms of iron. Sodium, if it is pure metal, it contains only atoms of sodium. Graphite, diamond, if they are in their pure form, they have only carbon in it, carbon atom in it. Then sulfur, for example, rhombic sulfur, its formula is S8. It contains only sulfur atom in it. Then white phosphorus or red phosphorus, whose formula is P4. It contains only phosphorus atoms inside it. All these can be classified as elements, and they will be the only atom inside this container. So such compounds are pure substances as well as elements. Such components are pure substances as well as elements. Now what are compounds? Compounds may be a molecule. It is a molecule, but that molecule will have more than one type of atom in it. And the compound on the container will contain only that compound, but the compound will be a molecule having more than one type of atom. For example, the one that we said earlier, water, H2O. Pure water means it contains only molecules of H2O, but that molecule has two atoms of hydrogen and one atom of oxygen. So it is not the same atom. Clear? So that means molecule having one plus type of atoms. ammonia molecule, NH3. So it has nitrogen and 3 atoms of hydrogen. Similarly, whatever molecule you take that is diatomic or more, that means it contains more than one atom, one type of atom, not more than one atom, more than one type of atom. Then if they are in their pure state, you can call them compound. So matter on one type, you can classify them as pure substance. Pure substance means you will have only one type of component, and if that component is an element, that means molecule or atom that is of one type, then you call them as element. And that pure substance can be compound if it is a molecule having more than one type of atoms. Clear? So the other type of matter is mixture. So mixture means that it's exactly opposite of pure substance. In pure substance we have only one type of component. So in mixture, what will be like that? What will be there? There will be more than one type of component. So one plus type components. Again, mixture can be classified into two, like what we did for pure substance. It can be heterogeneous or homogeneous. So as the name implies, homogeneous means it contains more than one component. It's a mixture, but that their composition will be uniform. So if you take a glass of water and you dissolve, so you take glass of water and you dissolve some salt in it, that salt completely dissolves in it, and their distribution of salt inside the water will be uniform. Such a mixture is called homogeneous mixture. Again, I am repeating the example. You take glass of water, you add some salt to it, and you try to dissolve it. When it is completely dissolved, that means that salt is equally distributed throughout that glass. Inside the water, throughout that glass, that salt is equally distributed, which means that mixture of salt and water is uniform throughout. Their composition is uniform throughout the glass. Such a mixture is called homogeneous mixture. On the other hand, if you are taking some sand and putting it into water, and you try to stir it and allow it to stand for some time, you will see that many sand particles have settled down, some are hanging around, and will be a little bit turbid. The liquid will be a little bit turbid, which means that it is not a homogeneous mixture, but it is an heterogeneous, means that the composition is not uniform. If the composition is uniform, you call it as homogeneous. If it is not uniform, we call it as heterogeneous. One of the other famous example for homogeneous is air around us. So this air is a uniform mixture. That's why we can breathe oxygen from everywhere, because it's an homogeneous mixture. Oxygen will be present everywhere. If it was not the case, then you have to run for oxygen. So after some time, you will see that the mixture around your head will not have oxygen. Then you have to run for other place for the oxygen. It's not like that, because air is an homogeneous mixture. Okay, so homogeneous mixture means uniform, and heterogeneous mixture means non-uniform mixture. Okay, now I have certain compounds here. I have certain matter here, not compounds, certain matter here. What you have to do is you have to classify them, take them into their corresponding groups. So it can be homogeneous mixture, it can be heterogeneous mixture, or it can be element, or it can be compound. You have to identify. So what is hydrogen? To which group does it belong? It belongs to element. So hydrogen is element form, and diamond contains only carbon. So what will be that? It is element. Then water, it contains only H2O molecule in it, but it has more than one type of atom, so it belongs to compound. Then air, just as I said, it contains more than one component, but it is in uniform mixture, so we call it as homogeneous. Helium, it's a stable atom, it contains only atom, so it belongs to element. Iron, again element. NH3, it is in pure form, but it has more than one type of atom, so it is a compound. Sand in water, as I said, it won't be that uniform, It is non-uniform and belongs to heterogeneous since it contains more than one component. Carbon dioxide, again it's in pure form, but it has more than one atom in it. So carbon dioxide is a compound. Then S8, rhombic sulfur, which has only sulfur atom in it and it's pure form, so it belongs to elements. And finally salt solution, as I said, salt solution has salt and water, and also it's a homogeneous, so it belongs to homogeneous mixture.